The better way to understand Nginx is to follow one request through the decisions Nginx makes. Imagine the browser is asking for an API URL on example.com. The application behind the site might be a Node server, a Python service, a container, or a group of backend processes. That detail matters later, but it is not the first thing Nginx cares about. The first thing is that a connection arrives at a public address and a web port. Nginx is commonly configured to receive traffic on port 80 for HTTP and port 443 for HTTPS. When a connection reaches a port Nginx is listening on, it can accept that connection. This happens before the application root matters. At this stage, the request has not reached your framework, your controller, your middleware, or your static asset handler. It has only reached the edge process that is allowed to receive public web traffic. If the connection uses HTTPS, there is an early TLS step before the normal HTTP request is processed. The browser and server establish a secure connection. That is how one machine can host multiple HTTPS sites and still present the correct certificate for the requested domain. The important detail is timing. Some name and certificate decisions can happen before Nginx is matching the URL path. After the secure connection is established, Nginx can process the HTTP request. The browser includes the host name it is trying to reach. In our example, that host is example.com. Nginx may have several virtual servers configured on the same machine, and the host name helps decide which one should handle this request. This is one of the first places where developers often mix up two different decisions. Choosing the virtual server is not the same as choosing an application root. Nginx first narrows the request by the address and port that received the connection, then it uses the hostname to choose the matching virtual server. Only after that does it make decisions about paths such as API routes, static assets, redirects, or fallback pages. This explains a common deployment problem. If DNS points to the correct machine but the wrong site appears, the request may be reaching Nginx perfectly well. The problem may be that it selected a different virtual server than the one you expected, or it fell back to the default server for that port. In that case, the application is not the first place to look, because the request may never have entered the site configuration you thought it entered. Now, once the correct virtual server is selected, Nginx can look at the request path. If the browser asks for an API path, Nginx can send it toward the backend application. If the browser asks for an image, style sheet, or JavaScript bundle, Nginx can serve it from disk. If the browser asks for an old URL, it can redirect it. If the site is a single-page application, Nginx can fall back to the main HTML page so the front-end router can take over. The path decision is usually handled through location matching. The useful way to think about it is that Nginx is deciding which handler should process this URI path. A request for an API path and a request for a static asset may enter the same domain on the same port through the same Nginx process, but they can take different paths once the location decision is made. There is a small detail here that is worth keeping in mind. If a URL has query parameters, those parameters can still matter later. The application can receive them and Nginx can pass them along. But the location choice itself is based on the URI path. So if a request asks for an API URL with a query string, Nginx is matching the API path first. The query string is not what chooses the location block. Now take the static file case. A browser asks for a file such as an image or a built JavaScript asset. Nginx can translate that request path into a file path on disk, check whether the file exists, and send the file back directly. When that happens, the backend application does not run. That is not a workaround. That is one of the normal jobs it is good at. If the HTML loads, but the static assets fail, the problem may not be in React Express or whatever application framework you're using. It may be in how Nginx maps public asset paths to files on the server. The request might be handled completely outside the application process. Now take the API case. A request under an API path usually needs backend logic, so after Nginx matches that path, it can forward the request to another server. That server might be running on the same machine on a private port. From the browser's point of view, the request went to the public domain. From the application's point of view, the request came through Nginx. This is reverse proxying. Nginx receives the public request, decides that this path belongs to the application, creates an upstream request, sends it to the backend, receives the backend response, and then returns that response to the browser. The application is still doing the business logic, but it is no longer the first public system receiving the request. Proxy headers are important. If the application needs to know the original host, protocol, or real client IP, Nginx may need to pass that information along. The upstream destination does not have to be a single process. Nginx can route to a group of backend servers. The public side can stay the same, while the internal backend changes from one app instance to several. A request can be sent to one instance, and another request can be sent to a different instance, depending on the load balancing behavior and configuration. This is one of the reasons Nginx is so useful in real deployments. The public entry point can remain stable while the internal application layout changes. You can add more backend instances, replace a container, move a service, or separate static files from API traffic without asking the browser to know any of that. The browser talks to one domain. Nginx can add or change response headers before the browser receives the final answer. That can be useful for cache behavior, security headers, or other edge-level response policies. This is not application logic, but it still affects what the browser sees. If compression is enabled, Nginx can compress suitable text-based responses before sending them to the browser. HTML, CSS, JavaScript, and JSON are common examples where compression can reduce the amount of data transferred. Caching can also change the request path. If proxy caching is configured, Nginx can store certain upstream responses and reuse them later. The first request may reach the application, but a later request for the same cacheable content may be answered by Nginx without contacting the application again. The important thing is the order. If the wrong side appears, start by thinking about the port and host selection. If the right side appears but a route behaves incorrectly, look at the path matching. If static files fail, check how request paths become file paths. If the backend receives the wrong host, protocol, or client IP, check what information Nginx passes upstream. If responses behave differently in production than locally, remember that the response may be passing back through Nginx before the browser sees it. What I find impressive about Nginx is how much control it gives you at that boundary. It lets you keep public web traffic in one place while deciding which parts should reach the application and which parts should be handled earlier. Static files can avoid the app, API traffic can go to a private service, multiple app instances can sit behind one public domain. That's it.